Hello everyone, welcome to this session. Our chapter is waves. So we're discussing about the waves. But in our previous video, we are discussing simply more introduction to the waves. We saw the various common terms that are used in waves. So today let's move on to the other subtopic, that is wave equation. So in waves, we will see that there is a wave equation. The wave equation is simply what it is, that it shows the relationship between the speed, the wavelength, and the frequency of the wave. So the wave equation it shows this relationship between the speed of the wave, the wavelength of the wave, and the frequency of a given wave. Now, previously we've seen that the distance covered by a complete wave, we said that is known as the wavelength of the wave. Now, likewise, the time taken by a wave complete its oscillation is what we call the period. Now, from there, from the common speed equation, that we know that speed is equal to distance over time, but distance moved by a complete wave, we say that equals to wavelength, and the time taken by a complete wave, we say that is period. Now, speed will simply be equal to wavelength upon period. Now, it is known that period is just equals to 1 upon the frequency. So the speed will be equal to wavelength upon 1 over frequency. Now, linear will be equal to speed equals to wavelength times frequency over 1. So the speed will be equal to frequency times wavelength. So this is the wave equation. So wave equation simply shows the relationship. We say that shows the relationship between the speed, the frequency, and the wavelength of the wave. So the wave equation, it is that the speed equals to frequency times the wavelength. I hope that's clear. Now, generally, the above equation, it just tells us the relationship between the speed, that is denoted by V, wavelength, and the frequency of a wave. Now, another important point to note is that if speed of a wave is constant, then the frequency of the wave is simply inversely proportional to the wavelength. So when the speed of a wave is constant, we can say that the frequency of the wave is inversely proportional to the wavelength, meaning that when the wavelength increases, the frequency of the wave will decrease, and same likely when the frequency decrease, the wavelength will increase. That's the meaning of the inversely proportional. Now, as you can see, so V is equal to F, this as frequency times wavelength. So when you make F the subject, so F, that is the frequency, will be equal to speed upon wavelength. So when the speed is constant, so the frequency becomes inversely proportional to the wavelength, as we've discussed earlier in the previous slide. So the above equation simply tells us that the frequency of the wave, the increase in the frequency of the wave makes the wavelength to be decreased, and the decrease in the frequency, it causes the increase in the wavelength. So that's the meaning of the inversely proportionality of this kind of equation. So this means that high frequency waves have shorter wavelength, and the longer waves have low frequencies. So that's simply the meaning of the above equation. I hope that's all clear. We've simply seen the wave equation, discussed it in briefly and in detail, just to understand the frequency. The wave equation. We've seen that the wave equation is simply the relationship between the speed, the frequency, and the wavelength of the wave. I hope that's clear, and thank you.